Rico. So my name is, yeah, hi everyone who've joined. My name is Adarsh. I'm the hackathon manager with Hacker Earth, and I'm here to inform you that I'm really glad that you all joined today's session for Oracle Hacks. Really appreciate that, and I would like to introduce Lorenzo, who is the Director of Innovation with DLT Science Labs. Thank you very much, Lorenzo. You can take over.
Thank you very much, Adarsh, and welcome everybody. It's a pleasure to be here with all of you today. As was said, I'm Lorenzo Palmieri, the Director of Innovation at DLT Science Foundation, and we are very excited about sponsoring our first hackathon and have many great people interested into that. The workshop will be carried out by our partners at Swirl Labs and Arkhia. So the former here would be represented by Abri Castro, the developer relations at Swirl Labs for Hedera, while the latter by Daniel Costa, the CTO at Arkhia. Also a very big thank you to our partner Hacker and our donor Hedera for making this event a reality. Thank you very much, enjoy it, and Adarsh, over to you.
Thank you very much there. And yeah, so let's start with the session, Lorenzo. So yeah, Abby, you could start with your presentation right after this. And yeah, the recording is on.
I'll go ahead and get started. All right, can you see my screen?
Yes.
Yes, we can.
Perfect. Okay, well, thank you. Thank you, Lorenzo. And thank you everybody for being here. I'm gonna go ahead and get started. So my name is Abby Castro. I am Developer Relations at Swirl Labs. I'm one of their Developer Relations engineers. And something, fun fact about me is that I have 4 dogs. I absolutely love animals, specifically dogs, and I wanted to just quickly introduce them to you. I have Charlie up on the upper left and Nori with the red ball, Luna the Siberian Husky, and then I have Snuffles on the bottom left. So you could feel free to connect with me over Twitter or over LinkedIn, and you can see that I have attached my handles on the bottom left. Another thing about me is that I value maintaining the integrity of natural systems, and I'm proud to be part of the developer relations at Swirl Labs, supporting Hedera, which is the greenest and most used sustainable public ledger for the decentralized economy. I was previously a full stack software engineer, and I really enjoy the opportunity to connect with other developers and have conversations about any preconceived ideas they may have about something restoring the imagination of what could be possible. So for today's workshop, it's going to be about an introduction to Hedera, and the title is Build Scalable Web3 Applications. So diving in, you'll be learning about Hedera and understanding the Hedera network services. In addition, some tips on how to start developing, and then we'll end on where to learn more and all about the resources that are available for you. So before jumping straight into it, I'd like to go through the evolution of the web, because I think it's important in order to understand and empathize with Web3 and where it's going. We first need to think about how we used to organize our lives up until this point. So we can start pre-1970s, which was the analog era. And this was a time where a lot of businesses organized and tracked their information on paper. It was the simplest thing to do, and it worked. But some of the issues is that it wasn't very efficient. So once we hit the 1970s, we entered a digital era, which is where mainframes and computers came into play, and we were able to gain speed. So these computers were able to process the information a lot faster and way more efficiently than during the analog era. So as everything, went from pre-1970s to 1970s, we did end up entering entering the internet era in the 2000s, where we gained interconnected computers. And so in addition to speed, we had access and collaboration. So we now had this open access to information and the collaboration from people across the world. And this is a time where you could call it Web 1.0, where the internet was great for information exchange, but not necessarily for the value exchange. Most of these participants were consuming the information, but they weren't able to basically create. It was just a lot of static files and sites and text and images. And the people developing were developers, the ones who had studied and understood what the internet was during the 2000s. So as technology kept evolving, we eventually arrived in Web 2.0. And this is during the time where the action on the web became a lot more interactive. So we entered social media, everything became a lot more mobile. It was common to have a cell phone in your hand and be able to have access to this information and sharing very, very quickly. You also no longer had to be a developer to be a creator. Anyone could create. They could go online and find tutorials or find videos and find a way to get their voice on the internet. And so during this time, we ended up having some valid concerns that revolved around trust and access control, data ownership, and anything that had to do with large applications. And they were all very valid. We were very concerned about our privacy. And so this was a catalyst into entering the trust era in 2009. And this is the foundation of what Web3 is being built on, is the value exchange and decentralization. They're at the core of these peer-to-peer networks. And so the evolution of the web is something that's very important because it impacts everything that we do currently and in the future. And so at the core of this evolution are these distributed ledger technologies, which are also known as DLTs. And we can dive into that next. So what DLTs are is that they're these peer-to-peer networks or nodes that maintain their own identical copy of a shared ledger. So the image on the left shows that the entire network verifies, executes, and records each transaction without needing an intermediary. There's nobody in the middle needing to check everything as information is being given to all of the nodes. And so in contrast, we have the centralized ledger. And this one does require a central authority to update and communicate the records to all the participants in the network. And I want to highlight the three differences again between a distributed and a centralized. And it's that the distributed ones operate independently of a central authority, and the transactions are automatically mirrored across all of the nodes, sharing the information very quickly. So now that we know those key differences, we can go into some of the components. So we know that DLTs have no central point of failure to attack. They rely on strong cryptography to move and to prove data integrity and tamper resistance. And in addition, there's a governance structure and a consensus mechanism. And this is required in order to update the ledger. There are three main building blocks that all DLTs have basically. There's the ledger itself, which is number one. And then number two is that there's a consensus algorithm. This ensures that all copies of the ledger are identical. And the third one is that there are incentives or rewards for the network participants, which are the nodes processing the transactions. And I'd say one of the most common rewards have been in the form of cryptocurrency. And so bringing all of this back to Hedera, Hedera is a third generation public distributed ledger, or DLT. And Hedera provides 10,000 transactions per second, costing 1/10 of a cent per transaction, with the final consensus confirmation in 3 to 7 seconds. And it's come a long way from the first and the second generation networks. But one of the aspects about Hedera that I really enjoy to talk about is how energy efficient the network can be. So the UCL Center of College for Blockchain Technologies created a research report where they studied a lot of different networks to see what their energy consumption was. And their newest report shows that the more transactions that occur on the network for Hedera, the energy consumption is lowered even further. And this chart here shows that Hedera uses 3 millionths of a kilowatt per transaction, and that's about 1,000 times less energy than a Visa credit card per transaction. And so all of this has been made possible with the superior algorithm that powers the Hedera network, which is what I would like to talk about next. That algorithm is called the hashgraph. And beneath the surface of the hashgraph, it's a different structure that solves the same problems as traditional blockchains, but it's slightly different. So let's bring our attention to the traditional blockchains first. We know for working with proof of work, it will typically take a lot more computational requirements, which will mean it will be more, it'll require more energy. And there's also no guaranteed consensus, and to some degree inefficient because you have to stale some of the blocks. On top of that, it is slow, but for security reasons. For the hash graph, it's an open source consensus algorithm and data structure, and this allows a network to have the carbon negative infrastructure. It uses a directed acyclic graph, also known as a DAG, which internally uses gossip about gossip and virtual voting. And this is the heart of this new technology that enables that high throughput that allows this to be the most sustainable, and it reduces the costs drastically compared to some of the first and the second generation networks that we saw in the previous slide. So instead of pruning for the hash graph, you are weaving everything back into the body of the ledger. So let's jump into the overview of the network. We talked about the consensus algorithm, which is one of the first things that make up the network. And next we have the network services. We have a consensus service, the token service, and an EVM compatible smart contract service. I will dive deeper into each service as we go through, but right now I'm just giving you an overview of the network as a whole. So next to these services, we have the governing council, which is a group of organizations that come together to help make decisions for the network. It's made up of large companies and top universities, and it brings decentralization and transparency and trust to the governance of the network. On top of this foundation is where we have our applications, and these applications are built for data integrity, tokenization, decentralized identity, supply chain, payments, and a lot more. Diving a little bit deeper into the governing council, which brings the stable governance and the treasury management, the mainnet operations, and decisions via voting, this slide highlights some of the Hedera's global governing council members that are currently part of it right now. So we have up to 39 organizations from a variety of industries, continents, and countries, and they all come together to make future decisions on the network and the product roadmap. I'd also like to highlight that each governing council member is required to run a node. They are also diversified through time, meaning that they can serve up to a 3-year maximum with up to 2 consecutive terms. And once their term is up, that organization that is leaving is then going to bring in a new organization to take their spot, making sure that it's not just an empty spot. Each member also has an equal influence of 1 vote. It's also important to note that there's different levels of decentralization within DLTs. It's something that is unique to each DLT, and that's something I'd like to talk about next. With one dimension, a DLT can be permissioned or permissionless, and in another dimension, they can be public or private, and any combination of the two, we end up with these quadrants. The public and permissionless are the highly decentralized. And in today's landscape, those are the Bitcoin and the Ethereums that we know. The public part means that everyone can build an application on the network. And the permissionless one means that anyone can run a network node. There are public permission networks, and this is currently where Hedera falls. Anyone can build applications on the network, but the nodes that constitute the network have to be invited to join in. There's also the private permissioned, where the nodes can freely join and anonymously, and that's the permissionless part, but the applications that are deployed have to be invited to join the network, and that's the private aspect. Finally, we have the private permissioned, which offer the least decentralization because the applications and the network nodes running those apps must be invited to join the network and provide some form of identification. So Hedera is currently in the public permissioned, where anyone can deploy applications. However, the network nodes do have to be known and invited. We're currently on the path of becoming public permissionless, And this is a little insight on our path to decentralization. The first phase starts with the governing council, which we currently have of these reputable companies and universities operating the network in all various continents except Antarctica. And phase 2 opens the network to community nodes. This is where everyone knows who they are, but they are able to run a community node. Last year, we introduced staking, and staking has enabled a mechanism for the community to use to contribute to consensus. It's going to open up even more once community nodes come online. Phase 3 is the most decentralized, and it opens the network to anonymous nodes, where anyone can run the node and contribute to the consensus. This, again, represents the network in the most decentralized state. As the network continues to grow in use cases, we have over 10,000 developers attending global hackathons and meetups and are active in Discord. There have been over 2 million total accounts created, with the network doing more than 40 million transactions per day. And there are over 200 applications in production on mainnet since open access in 2019. And a good variety of these use cases are by individuals and smaller teams. So let's dive into some of these network services which developers are using to create these use cases. So we'll focus on these three: the consensus service, the token service, and the EVM-compatible smart contract service. Our network services are available through our SDKs in the following languages: in Java, JavaScript, Go, and in addition, we have an awesome community-authored SDK for .NET. And recently, we also released a Swift SDK for mobile applications. So the consensus service, this is a topic-based publish-subscribe API. So what this means is that it allows you to create topics and subscribe to them and submit messages. This has topic management. These applications can subscribe to these certain topics in order to receive the messages that they truly need. And the consensus allows it to have an audible tamper-proof log of history that's provided by tying these messages together. You could have public topics or you could have private topics. In advertisement, there has been a lot of intermediaries and fraud in the industry. And so AdStacks has provided a verification of events and engagement using the Hedera consensus service without the high cost that third parties would have charged them. This data integrity and advertising, which is really important. In addition, the message processing and the storage is kept outside of the network to allow for higher speeds and scalability. You have the choice to keep everything, nothing, or something in between. The Coupon Bureau has also seen a decline in the use of coupons due to the lack of standardization and the susceptibility to fraud. Using the Hedera consensus service, it has increased traceability by being able to trace the life cycle of each coupon from the creation to the redemption of the coupon. This raises the transparency and the trust, and it allows for a consistent view of data and real-time authentication of coupons. As we move on to the token service, this token service makes it really easy to issue native tokens, and you get to do it at a low predictable cost, meaning that you have the scalability of tokens up to 10,000 transactions per second, only costing you $1 in each bar to create a token type. EFTPOS is a household name in Australia, and they process a huge amount of card payments. And they've been trying to do a lot with Hedera so they can bridge decentralized identity to stablecoin and micropayments. Their solution has been to leverage the Hedera consensus service that we briefly talked about and the token service to enable secure and affordable micropayments for any of their users on the web. Smart contracts. So these are self-executing contracts, and they provide a lot of versatility. They could create independence by removing any intermediaries and enable trustless transactions. On Hedera, you can run smart contracts that were written in Solidity, and they are executed in the order that they are received. There's no need to pay extra to be included earlier in the history, and you have a choice to provide an admin key to a smart contract, which allows owners to make alterations to the contract if it were necessary. Smart contracts are EVM compatible, and they have a very fast performance of 15 million gas per second, costing you $1 in HBAR to deploy. In addition, they offer a very low carbon footprint. So why build on Hedera, and why is it the future? First, we must identify some of the challenges that most layer 1 networks have. These challenges make it difficult for them to get adopted and for people to start using them. Today's most networks are consuming large amounts of energy, and it can prevent you from meeting any personal ESG goals or environmental conscious goals that you may have as a person. So with low processing speeds that prevents you from giving users a good experience, it can cause a user that's using your application to have a not very good user experience. And this can make you less competitive to other applications who have a very positive and smooth user experience. High variable processing costs can also make it difficult to know where your profit might be. If you are creating a use case and you're early on, it's very important to know how much your fees are going to be so you could budget appropriately to ensure that you could offer the best service or product to your users. And some of the problems that layer 1 blockchain-based technologies have is that they have variable processing costs, which can make it very difficult to do that. In addition, there are vulnerabilities in their security based on how it has been architected, and that can be difficult for users who are open to attacks on the network, in addition to centralization and a lack of transparency. So Hedera's service guarantees that you will build applications with a high throughput, with the fair ordering, the low latency, and a very low carbon footprint. So in this session, you've learned about an introduction to Hedera and how the network functions and how you could start development. And next, we will learn about where you could learn some more. So the first step in starting to develop on Hedera will require creating a testnet account. So you could create a testnet account by going to portal.hedera.com/register. Once you register, you will be given a Hedera account that receives 10,000 test HBAR every 24 hours. So this means that you'll have enough test HBAR to work on the test network with any of your use cases without having to worry about running out. And where can you learn more? So there's documentation on our hedera.com/get-started, and there's guides, tutorials, and core concepts that you can read throughout so you can learn more about the specific service that you're interested, or go through a tutorial that's going to get you started and creating tokens using the JavaScript SDK, the Java one, or Go. There are some coding tutorials as well as videos. If you are more of a video or visual learner, you can go through some of the videos as they walk you step by step on getting started. In addition, there's a developer Discord, which has all of the community members from people who are following the network and their use cases to actual developers and builders on the network. And you can communicate with some of them and get to network and see what is going on. So I'd like to say thank you for this opportunity to speak about Hedera at this hackathon. And if you'd like to let us know how we went, you could scan this QR code and type in your email, answer, I think, one question, and then you will get a copy of this slideshow as well. So thank you very much.
Thank you, Abby. Really appreciate your patience, and let me see if there is any questions for you. So if there's any technical questions for Abby, you can put it on the Q&A. We can wait for another couple of minutes. Is that okay?
Yeah, that's fine.
Cool. Let me see if there is any questions. Got it. So if there's no questions, we can move to the next session. Will that be with, yeah, Daniel? Are you guys ready?
Yeah, hey guys.
Okay.
Let me just
Cool.
start my video as well.
Sure.
And I'll share my screen, and then I can show you a little bit about what we're up to I'll probably just share only Google Chrome. Yeah. You guys, let me know if you cannot see my screen. If you can, I'll just I'll just start my presentation. So thank you for your time and thanks for the previous presentation. Actually, there's a lot of stuff that also good to review and remember why Hedera protocol is so cool and why we're here on this journey as well, and really try to bring this to the massive use cases that is so much needed. So what is Arkhia? Maybe you guys are, not everyone's probably familiar with it. So I'll just try to kind of give a little bit of a breakdown about what we are about. Just to let you know, you guys can visit at this moment as well, arkhia.io. So that's our main website. And what we are fundamentally is an infrastructure as a service, and also trickling down in software as a service, specialized on the Hedera protocol. So let me just open my slides and I'll just go a little bit about why do we exist and what's our purpose. So as Hedera, as we said, we specialize in Hedera, and basically what we provide is infrastructure as a service, and mostly and API suites and tools. What do we offer? Fundamentally, at the core level is a mirror node, a very high performant mirror node that obviously syncs with the rest of the node protocol around Hedera. Why do we need that? If you do want to tap into the Hedera protocol, there are some public services. You can also set up your own mirror node, but you'll soon understand that one, the public service might be a bit of a limitation for a production application, since it's not destined for this type of production usage. Getting a local node run does need some kind of lifting in terms of costs, in terms of infrastructure, in terms of skills, and keeping it maintained and upgraded. So it just starts to make sense having an external service that you can use of people that really put their focus and attention in making sure that type of array of nodes or services are scalable, are performant, are fast, so then you don't have to worry about any of that. And you can focus on actually doing what you love most, which probably is developing really cool applications with Hedera. So in a nutshell as well, like just to let you know a little bit about where we've been. So we've been supporting and working with Hedera for a while. Arkhia is built by developers for developers. So we really try to understand from our perspective, what do we need as a developer to try to get Hedera development on Rails? And I think we've been trying to pull out some tools and making sure all the integrations are quite smooth and really helpful for the community. Some clients that we support, so we work closely with Google Cloud. Also, they help us to make educated decisions about our infrastructure as we scale and move forward. Other clients that we have, Penguin, Hashport, probably heard of Hashbuck as well, Hashback, one of the main wallets, Swirl Labs, DAppRadar, Merkle Science. So, and all of them actually use Arkhia in a different way, which I will show you in a little bit. So like I was saying, and what is Arkhia, right? So basically, a gateway to Hedera, if from a development point of view, if you wanna put in that frame. Three main pillars that we offer. So infrastructure. So we do have a mirror node that auto scales and with dedicated bandwidth. So that means if you guys have a production application, if you're doing a marketing campaign, if you're doing an NFT campaign, if you have spikes of traffic on the weekend, if your application is scaling, you have a dedicated highway. So sometimes I like the analogy of a public road versus a private highway, right? So you can think about public services. Sometimes there's traffic. There's if you go on the weekend, there's not a guarantee that you'll get there in time. So think about us. If you do want your own private highway and your own private lane, that's what we do. We just give you all that bandwidth for access to our mirror node. A lot of stuff in the back. We do have security monitoring 24/7, load balancing, auto scale. So all that kind of stuff that is very infra related. And maybe that's just not something everyone wants to deal with when actually tapping into the Web3 world. So that's something we take care of. And the other one is the APIs. So we've been trying to have like a rich suite of APIs within Arkhia to make sure that every use case can be fulfilled, connected to our scalable mirror node. So we do offer the REST API and gRPC API. which for the people that's starting with Hedera, that's kind of like the bread and butter of the APIs exposed by the Mirror node and also by the public service. And we make it exactly like the public service. So if you need to switch to Arkhia, we'll be just adding an API key that enables you to tap into our infra. We've been quite a big fan of the JSON RPC relay from the beginning. So the JSON RPC relay allows you to interact with smart contracts, all that great work that's been done, contracts that are written in Solidity. So if you guys are comfortable with that language, it's very easy to transport them, deploy them on Hedera, and having all that power of this protocol, but interacting like a normal Solidity contract. JSON RPC relay allows you to do that, and also just use the libraries that you are very familiar with. So if you are familiar with EVM world like Web3.js, Ethers.js, it's really great because all you need is just using that relay, and it'll just do all that translation for you, and you'll be able to interact with contracts just the way you interact in the EVM world. So that's been like a great, really interesting tool. One last one is Watchtower. So Watchtower is a streaming API, allows you to get some data. So I think there was a conversation about the Hedera consensus service, and Watchtower is kind of an abstraction, a layer on top of it. That's an API that allows you to interact with topics and also dynamic balances from accounts, and you get all that pushed in dynamically. So it's basically a push system into your client. The cool thing about it is because it's using WebSockets, so you can actually use a browser for it. So if you do, you can literally just copy a snippet of HTML and can get you running. I'll show you in a bit. Besides that, we have the platform itself. So I'm going to show you a little bit about the interface in a bit. So I think we can just go through that in a visual manner. These are the APIs that we've been using, that we've been exposing. So you can see the gRPC endpoint, REST API, Watchtower, and JSON RPC relay, and just a few clients that actually been using more specific APIs. So where are we now? We have a bit of a growing ecosystem. I'll show you a bit of the tools that we have and what we've been coming up with. So just as a simple, it's kind of like a snapshot of what we're trying to say. Sometimes you build a great app, all of a sudden you realize like you're making REST API calls, you're getting this, you're getting that, and the public services may not hold versus the traffic that you're getting. And then you panic, and then you can use Arkhia and hopefully save your day. It hasn't been the first time sometimes that we did have people switching quickly just because they realized that a lot of the traffic that they thought they would have will be accommodated by public services, and then realize like you need a private mirror node provider. So don't take that out of your plate as you scale your application. Okay, so I think I'm done with this part. I'll just show you a little demo then. Like I said, you're more than welcome to go to Arkhia.io. I believe also DSF will provide you guys with a Rails, so they actually created an account with dedicated bandwidth for all your development needs. But I'm just going to show you a little bit about how to use it, how exactly do we get up to speed with Arkhia and the Hedera. So always feel free to create a page, create an account if you do, just to let you know, you have a little tab here for developers that will probably get up to speed with a few things. So one is the docs. This has a lot of stuff, including a lot of tutorials with code samples. So if you need to actually get a specific use case, let's say, you want to interact with a contract, REST API call, any of that, we just have a few snippets of code that can really get you running, and also just, a little bit about our platform, other stuff to get you started. So hopefully you will find anything that you need on this part. So the other one is the Explorer. So we have our own Explorer. So you can think, what is this? It's basically a GUI into our mirror node. So you can have a real-time snapshot about what's happening in our mirror node. So as you're using the SDK, you're writing tokens, you're writing a contract, you're deploying a contract, you're creating an account. Once that's pushed down to the mirror node, and including also Arkhia's mirror node. So this is connected to our mirror node. So you will see exactly what's going on and any type of information you may need. So this can be useful as well, just for you to understand, like, okay, create an account. Maybe you can put your account ID, does it exist? And here you go, so it can be a very nice helping tool at the beginning. Another one, just a bit off topic, but also just one thing that we actually created as well. And just for you to let you know, so this is a snapshot. Metrics Arkhia is just a snapshot about some data that is existing in the Hedera protocol. We will add more. So we're adding a lot more stuff in the next few months. But this is just a snapshot, so you can see the number of transactions that have happened on the Hedera mainnet, on the testnet, and then the highest TPS that's been existing in the current TPS that's happening both on mainnet and testnet. So that's something you guys can just check it out, just to have a snapshot about what's happening. Let's dive into the platform a little bit. So just to show you how does it work. So when you create an account, basically you will have your dashboard. Now you can create your own account also that will give you an operation, a little bit access to your own system. A few things here. So there's a network status that just always polls and makes sure like our nodes are in good health. So you can always come here and you'll see like you'll just have a comprehensive polling health of our nodes. Basically, projects is where everything starts. And this will actually be given by a DSF, so you won't have any problems. But each project will have an API key. And you can see this API key here. And this API key will be the path for you to kind of green light into our infrastructure. And I'll show you in a bit how does that look from a code perspective. Here you have all the services that you have available. So through that URL, you can actually have access to the REST API. We also have a GraphQL alpha that enables you to fulfill very small use cases. So we're working on hopefully extending that part. The JSON RPC relay, which will be very critical if you want to work with Solidity contracts, and Watchtower, like we said. You do have a stats page as well. So you actually can see the usage that people will have by project, also by week, current cycle, 3 months up to the last 24 hours. And then you can see, for example, for me, I have a granular detail about what kind of usage I've been having in my APIs to JSON RPC. You can see like I've been doing some little calls to get block by number, and also the Watchtower here. So one tool that I think could be really helpful for you guys to start is basically how to get started, how to get data from that. Like you need a snippet of code. You can obviously go to docs, but actually we also have a little debug tool that allows you to kind of tap into things. What happens is after you create a project, even if you have a free account, you can just play around with it. And what happens is, let's say you want to fulfill a use case. I want to get a specific account. Let me go, an account by ID, for example. All you need to do is send a request, and you'll have a snapshot of the payload that's coming in from the REST API, right? So at the moment you're supporting REST API and Watchtower. This can be quite helpful because you know what to map. And here at the top can be really cool because you can use, it gives you a snapshot about how does that request look like in several languages. So for example, if you like, let's say a very bread and butter type of usage, Node.js with Axios. So this is how it looks. It's very simple. So you're using a GET request. You have to have the URL, which will be given by DSF, and then the API key as well. And after that, you're good to go. And here you have a request of the accounts and many more, right? So balances, blocks, network, tokens. So this can be just a complement to the type of requests that you can do. Our requests for REST API, like I said, are exactly the same as the public node. So whatever you can do with a public node, you can do with us. And the only difference here in these APIs is really the header. So you just have to add this, or else you're going to have an unauthorized request, right? Because we're making sure that only private clients have access to our infra. Okay, just for Watchtower, just for you two guys to give a little bit of an example. So you can choose a topic here, and let's say if you want to use the Hedera consensus service, a publish-subscribe system that's decentralized, massively powerful for so many use cases. If you do want to try it out, you can just put the item ID, and you will have a snippet both in HTML and Node.js and React.js. So if you do want to try it out, it can be you can see it's as simple as putting the Watchtower URL, and then you can see I'm using a socket, right? So just regular socket library, available into almost any sort of language, and then all you need to do is just add a subscribe topic route, which is the path that you want to subscribe. There's a payload example, and that's it. So then it just streams down. And once these topics once you started this subscription, it just keeps on pushing anything new that might come in. Another interesting one is the account balance. So this is also available. And what we do, we can put an account ID, and it will give you basically a live update about the balance. So every time the balance changes, including any types of balances inside token or NFT related, I believe token related, it will give you basically a new payload with the updated balance. So this can be quite powerful if you're just checking for balances. You can think about wallet type of case or any type of thing related to that. If you want like a dynamic streaming, you don't want it to be like long polling all the time. This can be quite simple. And like I said, you can just go here. Okay, I want to get, even simple HTML, JavaScript, or I want to get in Node.js. You can just copy paste. You can go here and you're good to go. So I think this can be something. We do have support with a ticket-based, and for users, sorry, I was logged out. I think that's all in a nutshell. Just as other types of, we have a ticket support system, and in our users, we can enable auto scale. So actually, if you go, let's say if you have an account that allows you for 5 million requests, you need more, all you need to do is just auto scale here, you toggle on, and then we can just have an over usage fee that we agree later. Also teams, you can actually add people to your projects. And this is just a breakdown of the type of tiers that we have. I think I already talked too much. I hope I'm not bothering you guys with infrastructure. So let me just refer to things that might be of help as well, which I'll share gladly on Discord. So the services, the docs are documentation. So like I said, a lot of tutorials, also including demo applications. So there's one application that we just kind of showed, like if you want to deploy a Solidity contract, set up MetaMask, if you want to do some, this probably like it's a bit more of a complex part of dealing with a Hedera-based logic. So we do have a few samples here, and also we have an Arkhia playground, which has a lot of like little snippets, also with unit test-based type of samples that allow you to fulfill a few use cases. So doing REST API calls, specific also JSON RPC calls. So for example, if you are trying to call a contract, and if you do want to interact with it, we do have some samples that might be useful as you wanted to kind of deal with a little bit with the few nuances of working with this, right? So for example, here you use the JSON RPC testnet. This is the URL that can be given. Then you have the contract ABI. So this is all working. So maybe that can be of help for the developers' adventure for this hackathon. I think that's kind of it at the moment, what I wanted to share. So I'll probably just be quiet now and just open up for any questions or anything you guys might want to say.
Cool. Thank you very much, Daniel. Really lovely presentation there. Thank you very much again. And anyone from the audience who have questions, you can either raise your hand or put it in a Q&A box.
And just to let you know, I am in the Discord channel. So, if anything Arkhia related, just feel free to message me. I'll be happy to reply.
Yeah. I'll be also sending you the link to the Discord channel again on the next email. Also, we have posted the Discord link in the chat as well, if you've not already joined us there. Okay, so somebody mentioned here, could you also share GitHub URLs in the chat? Okay, thank you, Daniel, for that.
Yeah, so that's the one specifically for integration tests with the JSON RPC, but you can go back and you have a lot of them, like with REST API and everything. So I think that will be helpful. REST API should be a no-brainer. But I think, yeah, for the JSON RPC, happy to share those codes. Hopefully you guys can use it to fulfill any use cases you may have. So you have things there for contract calls, writing contracts, deploying contracts, which I think it's kind of like the skeleton if you do want to interact with it. So yeah, good luck, man.
Thank you, Daniel. Any more questions, guys, before we wind up? I think, yeah, that's it. So yeah, Ashish, we'll be sharing the recording. Yes. Cool. Thank you very much, everyone, for joining in today. And I really appreciate your time and patience. Thank you, Abby, Amanda, Daniel, Rico, Lorenzo. Thank you, everyone, for being a part of this. Any last words, Lorenzo, before we conclude?
No, I'm very excited to see the projects being submitted, the ideas first, and then the projects, and very much looking forward to work all together and start building something very exciting on Hedera. So good luck.
Thank you. I think we would certainly see some great projects in there, and I know people are really excited. And for people who couldn't join this session, we'll be certainly sharing all the information, including the recording as well. Thank you very much, guys, and have a good one.
Thanks, guys.
Thank
See you
you.
later.
Thank you.
See you on the channel.
Bye.
Bye bye, guys.